Okay, this is video 6 for chapter 7. It actually goes with section 7.5 in your book. There's a lot of different ideas and concepts that they talk about in this section, so we're going to start by taking notes on this sheet, and then there's more that we'll cover together in class. So this first part is all about scale factors and what they mean, how they work, what they do. So a scale factor, go ahead and write this definition. A scale factor is something you multiply by. Something you multiply by to make a number bigger or smaller. Well, we're going to say actually to make, usually in this case it's going to actually be a figure or picture, bigger or smaller. And we're going to see how that works over the next couple days. So, if I have, let's look at this table. If I want to make something twice as big, I could use a scale factor of written as a decimal or a fraction, right? I want to make something twice as big, so I would multiply it by 2. Or as a fraction, that's just a whole number, so I'm still going to just multiply it by 2. Or I could say I want it to be 200% bigger, 200% of what it is now. That would make it twice as big. So we can kind of think of scale factors as both percents, decimals, and fractions. So if I want something, if I have a scale factor of 3/4, that would make it 3/4 as big. Okay? Or 3/4 as a decimal, we should remember, we memorize these, 0.75, or that is the same as 75%. So if I go to make copies and I set the zoom or the scale to 75%, it's going to come out 3/4 as big as the original. Or if I copy something at 300%, well, that's going to be 3 times bigger, right? As a decimal, or it's just a whole number. So 3 times bigger. Or if I multiply something by 1.5, it's going to be 1.5 times bigger. Okay, 1.5 is a fraction, so think of your improper fraction there. 1.5 would be 3/2. Or that would be the same thing as kind of copying something or zooming something to be 150%. Okay. Well, what if I want to make it half as big? Well, to make something half as big, I could multiply it by 1/2. Or as a decimal, 0.5. Or I could copy it at 50%. Okay. So you're starting to see how these scale factors work. It could be a fraction, decimal, or percent, and then it's going to have some result when I multiply by that. 0.33333 repeating, if you recognize that one. So that is our fraction 1/3. If I want to make something 1/3 as big. Okay, or that percent would be 33, repeating, percent. Okay, so we've done one whole table together. I want you to do this one. So you're going to finish filling in. I've given you something to work with on each line. Fill in what the rest of it would be, and then make up your own at the bottom. So pause, and then we'll come back and check this. Okay, so check this chart here. I filled it in. I'll leave it up for just a second. You should be able to convert back and forth between those fractions, decimals, and percents, and then tell me what the result would be if I use that as a scale factor. Okay, you need something different down here on the bottom one because you need to make up your own. So pick something else to put there. So finish checking, and then we'll go on to the next part. So we've already said that scale factors could be fractions, decimals, or percents. They can be bigger one and they can be less than 1. So let's talk about that a little bit more. You need to give me some more examples of scale factors less than 1. So a fraction that's less than 1, 1/4. Come up with 4 more examples of fractions that are less than 1. Or decimals less than 1, 0.15, that's less than 1. You come up with 4 more that are less than 1. And percents, so now I need a percent less than, remember that's the less than symbol, less than 100%. So I could use 40%. You come up with 4 more, okay? And all of those examples of scale factors that are less than 1, it says what will happen with any scale factor smaller than 1? Well, if I multiply by any of these things, the fraction, decimal, or percent, the thing that I'm multiplying by is going to get smaller. The value is going to get smaller. The size is going to get smaller. Whatever I'm multiplying by will be getting smaller. And then I need 5 examples of scale factors that are more than 1. Give me fractions that are more than 1. Well, more than 1 as a fraction should be written as a improper fraction. So maybe something like 5/3. Give me 4 more. Decimals more than 1. 2.6. Give me 4 more that are more than 1. And then percents, more than, greater than 100%. So I could use 300% or 275%. You give me 4 more percents that are bigger. What do you think is going to happen now if I use a scale factor that's more than 1, or if I copy something at more than 100%, it's going to get bigger. Okay? So we actually have special words for this. If something gets smaller, we call it a reduction. And if something gets bigger, we call it an enlargement. So those are words you're going to see again. Write those down. Okay, this next one says finding new dimensions. Well, if I give you the scale factor, so I give you what we start with, and then I give you the scale factor to multiply by, you tell me what my new dimensions will be. Let me switch pens again so you can read it. If I start with something that's 8 feet by 12 feet, and I want to change it by a scale factor of 2, well, this means it's going to get 2 times bigger. So instead of 8, now I'm going to have twice as big, 16. And instead of 12, twice as big, 24. So each time you're just going to take the original dimensions, multiply it by your scale factor, and tell me what you get. Remember, if your scale factor is less than 1, your number should be getting smaller. So a scale factor of 1/2. Half of 14 would be 7. Half of 10 would be 5. So I'm going from 14 by 10 to 7 by 5. Okay? Let me do a couple more, and then you can finish the rest as practice. So a scale factor of 3. Multiply each of your original dimensions by 3. 6 times 3. 12 times 3. 18 times 3. Okay? And keep the units on there. I'm talking about feet in each of these. All right, one more. 9 times 1/3. Well, remember, I'm going to divide by this. It's the same as dividing by 3, or 1/3 of 9, and then 1/3 of 12. Okay, so try the rest as practice. Remember, we have shortcuts for doing these in your head. Divide by that denominator, and then take your answer and multiply it by the numerator. That's our shortcut without a calculator. So finish the rest of these, and then we'll come back and check. Okay, here's what I got. Make sure you actually know how to do this, and don't just copy them down, because you're going to see questions like this. So let's check, starting with here, I just multiplied them by 5. Here, remember, I would take 14 divided by 7, that's 2, times 2. So I got 4. Or 21 divided by 7 is 3, times 2. So I got 6. Finish checking these and make sure you're okay with those, and then we'll flip it over and do the back. Okay, on the back, my biggest hint to you is to color code. Get some markers or colored pencils. If you need to, go grab them now. Get colored pens or something where you have different colors. Okay, and then we'll go over a few examples together. So to find a scale factor, if I'm looking at pictures, I have some similar shapes here. Remember, we've talked about similar just a little bit. It means, let's write this definition down. Same shape, different size. So we need that definition of similar written down. Same shape, different size. And what's also important is that we know that these are going to be proportional. They're going to be proportional to each other. That's going to be really important as we solve these problems. Okay? So similar figures, same shape but different size. You can see that in all the pictures here. First step is to match up corresponding sides. So find the sides that pair up together. Pair up or match up. Okay, the sides that go together. Okay, once I have those sides, that's what I'm going to use my color coding for. Then step 2 is going to be to write a ratio. And that ratio needs to be new over original. Put a box or star or a circle around this. This is going to be important. I want to write a ratio of those corresponding sides, but I always have to write it new over original. So this is going to be a fraction. It's going to look like a fraction. Okay? And then step 3, simplify. Simplify that ratio or fraction. So let's do a couple together. All right, find corresponding sides. Well, I've got a side here that pairs up with the side there. Okay? If I want the scale factor to go from little to big, I want to know what would my scale factor be to enlarge it and make it bigger. Well, I'm starting with this and going to this. So this is my new shape. This is my original shape. Original, new. So I take those two corresponding sides and I write a ratio, new over original, 9 over 6. And I simplify it. And that's my scale factor. Scale factor going from big to little. Well, now I'm going the other way, starting with the big one and making it smaller. Now this is my new, this is my original. So all I really do is flip the numbers over. Now I have 6 over 9, or that simplifies to 2/3. Okay? Let's try one more. Let's do number 2. Scale factor from little to big. So let me find the sides that go together. They're labeled right there. Little to big means I'm going this way. I want to make it larger. Okay? So this is my original. This is what I'm turning it into, my new. 51, I'm going to come over, well, I don't have a lot of room, but 51 over 17. That actually does simplify. That simplifies to 3. So this is getting 3 times bigger. Okay, going the other way, scale factor back, big to little. Now this is my original, and this is my new. 17 over 51 simplifies down to 1/3. So this is 1/3 as big. Okay, I want to look at number 4 because it's a little confusing. They're going different directions. The shapes don't look the same, so I have to think a little bit harder about which ones pair up together. So I'm going to find the shortest side here and the shortest side here. That's why I'm color coding them. Those would go together. Or I can find the longest side here would go with the longest side here. You have to find the corresponding sides before you can get a scale factor. But once I find corresponding sides, pick any pair. I can use the orange ones, I can use the pink ones, doesn't matter. Let's go with the pink ones. So little to big, this way, getting bigger. New, 35. Original, 21. Simplify, looks like I could divide by 7, 5/3. Going the other way, so now going this way. Now 21 is my new, 35 is the original. I'm still sticking with the pink ones. And I get 3/5. Okay, so I have a scale factor going both ways. One of them is bigger than 1, one of them is less than 1. I want you to try these. We're going to do a whole lot more practice in class, but I want you to at least try them. Color code them, write a ratio, simplify the ratio in each case. Just make sure you do new over original. Okay, so I want to give you time to try those and come back and check. Pause now. Okay, so in this one I've paired up the pink lines. I could have done the same thing with the yellow and they should give me the exact same answers, but write them as a ratio and simplify it. Here, same thing, I used the pink ones in this picture, but I could have gotten the same answer with the yellow sides. Doesn't matter, just make sure you don't mix and match. Number 6, again, the 15 and the 24, and then simplify them. The only key here is make sure you do new over original. If it should be getting bigger, then I should get improper fractions, more than one, that will make it get bigger. If it should be getting smaller, make sure that I have regular fractions less than 1. That will make it get smaller. And then check the bottom ones as well. So completing this sheet is what you need for video 6, scale factors.